Alright, welcome back. This is kind of the second video of updates on 616os. If you haven't seen the last video, I'd recommend you go watch it. I think it's cool. An assembler and a kind of interpreted scripting language. But you don't need to see it by any means. We kind of spoiled some of the stuff for this video and that one too. But yeah, you can also watch like the last two videos. As well. That one on like is the very first show off kind of demo. So that was actually kind of a long time ago, at least like long time ago sort of. And then also why I switched to the cx16 as sort of the sole CPU supported for this project. So let's get started. So we're sort of going to be talking about sort of the changes to the file system a little bit. Kind of how I went from carriage return to line feeds, and also pipes, which I think is the most exciting part. Let's just talk about the carriage return to line feed thing. So yeah, I changed kind of the new line character from the carriage return to the line feed. So yeah, in the CPM kernel, the carriage return is the line, is the character to kind of go to the next line, and the line feed doesn't really do anything. And I was gonna initially I kept that behavior, but it was kind of, especially when I was writing more C programs, it was sort of annoying because it's also like POSIX expects. I was trying to get a little bit more sort of that, not like become compliant with POSIX obviously, but kind of go that way to kind of what direction it should be going. And line feed is standard as like the new line character. I also think like the carriage return is a cool character to have it on its own. So it being the line feed character, or it being the new line, means like I don't have that character. So I was like using home, and it was like different behavior. So I decided it was just easier to use line feeds, and it like when you're printing stuff on Unix, sometimes it just doesn't work. So I figured let's just do this. It actually really was not too hard to change. Basically every program, some of them only referenced it once or twice, and I could just replace, find and replace. So the programs were easy. The OS was a little bit more difficult. I basically mapped it so whenever you request a character from the keyboard, if it were to return a carriage return, it just returns a new line instead. Which is probably not the most elegant solution, but I think it's fine, especially because you're just going to call get in half the time anyway. So it was really fine. I might go back and change that to be a little bit better, but for now it's good. And then yeah, so that was pretty easy. One thing, Ed was like the one program I actually had to think about, because Ed used to strip it. Like if there was a line feed after a carriage return, it would strip the line feed, like the proceeding line feed. And obviously you don't want that behavior, because then you will never, if you have a bunch of line feeds in a row, like then it won't work. But yeah, it was like not super hard. So now if you just xxd, like, I don't know, let's just echo hello. Obviously this is getting to the pipes, but if you just like you can see that the character at the end is a line feed and not a carriage return, because line feed is 0A, carriage return is 0D hex. The next thing was sort of the changed file system layout, which you obviously saw in the last video. But so yeah, the file system layout changed. It was sort of getting annoying to have like a bunch of I just wanted a location where files could go that weren't like just like sort of the root directory. Although it's kind of so I was kind of talking about myself, do I want this to like literally have to run in the root directory? I think that'd been kind of annoying. So what we have here is that this is sort of like the root directory of cx16os. It's the ampersand, the tilde, sorry. And normally this is sort of like the home directory in a Linux setting. But that's not really what it is here. So like normally you wouldn't have like you wouldn't like do like ls tilde slash bin or home slash bin or whatever. But that's sort of how it works here. Like, so yeah, I mean that prints all the binaries, but that's normally you do like ls dash bin or slash bin, which obviously doesn't exist here. And I thought this was kind of fine because I think it's helpful potentially to like obviously I don't have any other programs on this disk. Sorry, on this SD card because it's just an image. But on my real commander, I can like navigate over to other programs and I can like hex dump them, and I can cat or I can more through them to like go through them one line at a time, stuff like that. That's useful. That you'd want to be able to access other files for, and it would sort of make it weird to. I don't know. It kind of. I also think it kind of looks ugly to have like a bin folder on your root directory of your SD card for the rest of your life. For one application. So I figured we could keep it like this, and I think that's fine. I don't know if this was here last time, but if you use cd with no arguments, it will go to the home directory. This is sort of it'll like the shell basically just cds. It will do this. I think it's like hard coded in the shell somewhere. Now this is probably getting overkill. Now this. Well, while I'm talking about this, why don't we talk about pipes? So yeah, now we have pipes. So you can actually pipe program output from one program to another. So in this case, we have the XXD, which is like a hex dumper program if you've never used it before. And then also just a program. More is just like one line at a time through a file. Okay, I think I'm just. Okay, that. Sorry about that. Yeah, so okay, why don't we just try to strings it? I'm pretty sure that the version of strings I wrote is slightly buggy, but it still kind of works. But yeah, so you can see slash home at the top there, or towards the top there, the third line. So yeah, that's a hard coded thing. But yeah, sorry, yeah. So home is sort of the starting directory now, and it's an easier place to put my files, and then it kind of lets us separate it from like bin, etc. Temp. Oh, is there anything in temp? No. Yeah, bin, etc. Home. So they're all sort of like, it's a little more. I think makes a little bit more sense just to not have like, because I mean normally on like a Unix system you'd have like it'd be home slash like user, so Cameron or you were cut off. Sorry, I didn't mean to do that. Okay, sorry, my OBS was screwed up. But yeah, so you'd be home, cat, stuff like that. But or home in your user, but in this case we just have home, which I think is fine because this is obviously a single user system, so I think it makes plenty of sense. So yeah, pipes again. So yeah, pipes. So there's two ways you can do it. You can't. There is basically it's an unnamed pipe. It's not a named pipe. There are the named pipes are sort of like the hooks, which are through send message. But yeah, so there's a pipe, basically like there's a pipe routine which is almost identical to the C function. It returns two file descriptors, a read end and a write end, and then you pass it to other processes. So basically, the shell, what it will do is it will open a pipe, put one end, it will set one end to be it'll set the read end of the pipe to be the standard out of like ls here, and then the standard in for xxd will be the right end of the pipe, or the right end of the pipe will become the standard out for ls, and then the read end of the pipe will become the standard in for xxd. And you can kind of see that there. And it's actually kind of surprisingly quick, actually. I'm happy with that. But yeah, so that's sort of the basics. I mean, obviously, I can't really show you the internals. I can show you a little bit of the internals actually in the disassembler. So these are actually stored in banked RAM as well. So they're stored from they're stored at A00 to B00 in banks 2 through 0F. So up until like the first program. So if we go here, 0F. So 0F is actually the first one. You can actually almost see a little bit. So even if you like tab back and forth, you can kind of see the output here. So it just basically it's a ring buffer, like sort of like the general, somewhat similar to the general hooks, kind of that probably under discussed in previous episodes. Kind of this code. But yeah, so that's all stored here, and then at 0FB00, the ring buffer is at size 1000. You can kind of see the pointers here. So A054 is like, so yeah, right now they're equal, which means there are no more bytes to read. So yeah, which makes sense because like all the bytes were read. And yeah, that's pretty much that's sort of it. Or not. That's not it, but that's a little bit of that's most of the internals I could show you. Obviously, I guess I could show you maybe if I can get it to like. This is might crash. Sometimes this stuff does. Yeah, sometimes it's I don't know. Sometimes it's like. Yeah, so you can actually see like a bunch of. So this is to play Macbeth. I feel like people use Shakespeare in their examples a lot of the time. But here you can see that the right end or the that one pointer is greater than the other, which is basically the bytes that haven't been read yet. So yeah, so this will continue dumping the whole thing. It will take a while, obviously, because it's it's a long play. It's a whole play, and I don't know why that was slow. Yeah, I mean, even catting Macbeth takes like a minute. So if you're interested in a speed comparison, if you try to cat a file on Linux, or if you just cat a file like in Ubuntu, I said Linux is really weird there. But if you cat a file in Ubuntu, it takes like less than a second. So this is a little bit slower here. But it is a 8-bit or 16-bit machine, so cut it some slack. Um, but yeah, I mean, this is the whole thing. You can press Control to slow it down, which is this CBM thing. But yeah, so why don't we look at some of the. Let me Control CPAT. Why don't we look at some. Actually, while I'm here, I'm now going to highlight that you can use Control D to basically close a program standard in. And you can also use so if I like this if I do this Control C, it will not actually print it again because that kills the program. So you can either use Control backspace like an non-maskable interrupt then NMI, or you can use this. So you can also we'll try it with Control backspace. Alright, this actually won't work because I disabled the emulator command keys, so I can't issue an MI. But if you have those on, it will work. FYI, if you don't use the no mu command keys option, Control D will detach the SD card, which is not what you want to do, obviously, because it will not let you load any more programs. You don't want to disconnect your SSD while you're running your computer. But yeah, so that's a cool thing you can do. But you can look at more. So yeah, Math.txt. I mean, this is not like the most interesting, but it lets you scroll through a text file. It is basic, like you can't go up. You can't go up, so you can only go down. You can press page down to go through a whole page, like so. Dunking is the last line here, and it will basically just get scrolled off the. So there's no monologues here. I can't. So Macbeth.com. Sorry, Macbeth.com. That was really bad. I read this play in school twice. I think I should know how to pronounce Doth. But yeah, so this line will just barely get scrolled off the screen. Um, so yeah, and then yeah, I mean this is the whole play. You can mash the page down a bunch of times to go to the end. You know, I do like this play, but that's not the point of this video. So yeah, you can do a bunch of like cool stuff. Like you can pipe cx16os. You can pipe it to itself, which is kind of funny. It just flows up out of the size, which I think is kind of funny. Or the size of the output. And you can also do like pipe. Does this work? I don't know. It doesn't. No, I think you have to do this. No. Okay. It doesn't. Okay. Well, I haven't implemented that yet. But you know, that's one thing you should be able to do in the future when I add that. Um, but you can word count Macbeth. Just give it a second. It's written in C, so it's a little slower. But yeah, but it's pretty big. You know, 4,800 lines. You know, 18,000, just over 18,000 words. You know, 100,000 characters. So you know that is a big text file, obviously. Trying to see if I can say anything else. Like, oh wait, you know, I had to show this cows. I also have a cow save program now. Sort of, you know, maybe this was the thing I had in school where all my professors just really liked this program because they thought it was kind of clever. But I do have a sweet spot for it, so I did kind of implement it. And it's a good example of piping. So you can either give it like command line arguments, and I mean you can even pipe it command line arguments, and it will just, if you give it command line arguments, it will ignore standard in. Otherwise, it will like you read. So you know, if you can give it hello world, and then I'll control D, it'll print that. And it does actually acknowledge color. I don't want to. If you try to like pipe a neofetch to, if you try to pipe neofetch to cowsay, by default it sort of looks weird because it kind of cuts off. But what you need to do is just give it a different width. So you can give it width 72, and you can also do -L, which basically just, it's sort of that every line of the piped in input will just be on its own line. By default, it will just add spaces in between. So if you can fit multiple lines, like if you have a very short line, if you have two very short lines, they'll end up on the same line of like the cowsay bubble. But in this case, it just makes it individual. So basically, in this case, it just gets wrapped. Otherwise, I think I can show you what happens if you don't do that. I'm not sure it will work. But it will look really weird because both these lines, this line and this line, fit on one line. But obviously, you don't want that behavior. Which this doesn't look. This is how it looks. It looks weird on Unix too. Like, well, why don't we do this real quick? Or, if I can use fetch pipe cowsay. Okay. I just reset my Ubuntu IWSL installations, so I need to reinstall those, and it's gonna take like. So please bear with me. Alright. Should be able to work. Yeah, I mean, it totally breaks. If you even scroll up, yeah, I mean, it just totally borked. I think even if you, I don't even know if this is an option, but we'll give it like with 180. Oh, but yeah, it doesn't work. There's probably some. I think it's -W. That looks, I mean, a little less bad, but obviously it still doesn't really work great. So I'm happy to say that my version looks better than the Perl script from like a long time ago. Yeah, so yeah, cowsay, again, obviously, ooh, yeah, it doesn't really look good unless you new line it. But yeah, so there's some example pipes. Oh yeah, why don't we actually go over that too? I kind of forgot about this. So, actually, an untar program got posted to the Commander X16 Discord, and I sort of a challenge to get it working in C for the commander. So I kind of took it. I was like, I have some portable functions. I think I can get this to work. So yeah, I kind of took it on myself, and it wasn't actually too bad, and I did get it working. So why don't we just make a tar directory so I don't. Also, it vastly improved the copy programs. Like you used to have to specify tar/out.tar. Now you don't. Now it recognizes what you want to do. So if we untar out.tar, not many arguments, it will extract all the files. I just made this tar directory, so it's very small. It's actually like ustar. It's a specific type of basic. It's like the most basic kind of tar directory, but it works. And this text file is just sort of like oh, you did it. You've unwrapped the tar ball, and this empty file is just empty. But yeah, the nice thing, I guess, that I think is interesting that I didn't have to do I barely had to do anything at all. Like it was basically I had to change like one or two functions, maybe. I don't remember what I did. I don't think I did much, which is kind of cool. Like we've gotten to the point where there's enough. Like I have run enough libraries that I can just write C programs and they work for the most part. Unless they're too big. That's like the only thing with 8K. But I have ordered a cartridge and it's on the way, and maybe we'll get 24K and get all that working. That'll be another video, obviously, but I think this can finally be it for now. So yeah, thank you all for watching. I really appreciate checking in on this kind of the status of this project. Pipes were kind of a goal for a while. Like I wanted to get it. I realized that I was kind of looking at at Unix like design a little bit more, or as how much like everything as a file is taken to the most extreme, which is not what this OS does. So it's really not designed to be so much like Unix other than the look. Like just from the pipes are the only thing that make it really Unixy, honestly. Uh, but I hope I think it's still okay, and I'm proud of this project even then. Obviously, you're not everything. It's probably better to do your own thing than just have to try to copy everything. There is Gitghost and there's Linux if you really want that. But again, yeah, thank you for watching this. The message has been scrolling down for a little bit now. Yeah, I've never tried this. But yeah, thank you for watching again. And I guess that's gonna be it for me. So yeah, have a good one, everyone.